Okay, so we're going to take a look here at scientific notation, and I just want to tell you in general what scientific notation looks like. It should be a number between 1 and 10 times 10 to a power, and that number specifically should be a number less than 10, but it can be greater than or equal to 1. So whenever you're trying to convert a scientific notation form number, so here's a decimal between 1 and 10 times 10 to a power, into a standard form number, what you're going to do is the number of tens you have here, if that's a positive number of tens, that, imagine, every time you multiply by one of those tens, the decimal point moves to the right. So multiplying by 10 to the fifth moves this decimal point 5 places to the right. So if I started here, it would move it over once, twice, 3, 4, 5 times, and 923,000 would be equal to 9.23 times 10 to the fifth power. So let's go ahead and let's try some other ones here. What if you have a negative power? Well, 2.15 times 10 to the negative third is scientific notation, right? Decimal between 1 and 10 and a power, but it's a negative power. So we know about negative exponents. That is like dividing by 10 to the third. As if I move this downstairs and I really have 2.15 times 1 over 10 to the third. Well, when you divide by tens, that moves your decimal to the left. So what would happen is if I started at 2.15 and I divided by 10 3 times, I would get 1, 2, 3, and I would get 0.00215. So whenever you see a negative exponent on scientific notation, you know that number is less than 1 in its full decimal form. But by the way, if it's 10 to the 0 power, you're not moving anywhere because 10 to the 0 is 1. So this really is 4.9 written in scientific notation. It's 4.9 times 1. So there's 0 movement of the decimal. Here's another negative problem. Okay, so we know, I said, anytime you have a negative power, you know your decimal form of this scientific notation will be less than 1. In fact, I should be dividing by 10 squared or moving my decimal from this original spot over 1, 2 places to the left, and 0.03444 would be the decimal equivalent. Let's go the other direction. Let's go ahead and start with a decimal form, and let's get it to scientific notation. So here's a pretty big number. If I counted back to get to a decimal between 1 and 10, it would take me 1, 2, 3, 4, 5, 6, 7, 8 spaces, or really 8 powers of 10, right? 10 times 10 times 10, 8 times times 3.7 would get me this. So what I do is if I had to count back 8 times or 8 spaces, I'll call my scientific notation 3.7 times 10 to the 8th, giving me that potential of moving this over every time I multiply by 10, 8 times, and getting this original decimal form. Okay, how about this then? This is similar, but I only need to go back 2 spaces. So this is 7.13 sets of 100. So it makes sense that I'm going to go and call this 7.13 times 10 to the second power. Now here's one we said earlier. If we have a decimal that is less than 1, its scientific notation should have a negative power of 10. Because if I have to move 1, 2, 3 places to the right to get to a decimal between 1 and 10, that is really 1,000 times bigger than the problem I'm actually trying to represent. So I have to counter it by dividing by the 1,000 that I increased it by. See, this was a 1,000 increase. So a 1,000 corresponding decrease is writing 10 to the negative 3, because that would be like dividing by. So if I multiplied to 1,000 to get to 5, I need to divide by 1,000 in order to counter it and still be equal to the original problem. This is one of these where I don't want to move it. I got a decimal that is equal, that already is between 1 and 10. So in scientific notation, it would just be this, times 10 to the 0 power. And this one's a little weird. I mean, it looks like we don't have to do too much to it, but it really is just a little beyond 10, right? We have to be less than 10. So we're going to want to move this over one place to the left. But now this is smaller than what I want to represent. So whenever you have to move to the left, you have to counter it by a positive power of 10. In this case, just 10 to the first for that one move. So, real quickly, I think it's probably worth giving a general statement here. When I move a decimal to scientific notation, if I have to move to the right to get my decimal between 1 and 10, then my exponent on my power of 10 is going to have to be negative. Why? This is making the number bigger, then this has to make the number smaller. But likewise, when I take a problem like this, where I have to make the number smaller, then I have to counter it by making it bigger. So watch this. We could call this a negative direction move to get here, positive exponent. Positive direction move, negative exponent. Okay, now let's take a look here at doing some actual operations, right? So if I had this in a science class where I was doing some calculations that were already in scientific notation, I could really kind of use the exponent rules we know, and I could really look at this problem as really 3 times 5, because these are all factors. We're not doing distribution here or FOIL. This is not a plus and plus or minus and plus or any kind of addition, subtraction operations. So here's what I really have. Right? So what I can do here is I could say that's 15. And what do? Like bases, we add exponents when there's multiplication. So this is times 10 to the 7th. But that isn't quite scientific notation, right? That is not a number between 1 and 10. So I'd like to call this 1.5, and because I had to make a negative decimal move to get to a decimal between 1 and 10, this alone is times 10 to the first. That's still 15. But then I have times 10 to the 7th still. So now I have 1.5 times 10 to the 1 plus 7, or 1.5 times 10 to the 8th would be the final scientific notation form of that answer. Okay, let's try a problem where we have negative exponents, and then we'll try a division problem. So what would I do? Well, I need my calculator this time, but I am still going to do this. I'll multiply the numbers. Then I'll do the powers separately. This is what? 10 to the negative second times 10 to the negative third. And let's see what I get here. I know this. I know I'm going to get 10 to the negative fifth here initially. But I don't know what this decimal is going to be, so I need a calculator for that. Let's take a look. 1.72 times 8.4, and that gives me 14.45. I'll call it 14.45. Well, once again, I ran into a little bit of an issue here because that is not quite scientific notation. So I do an internal adjustment to scientific notation of that number, which would be 1.445, and because I made a negative direction move to get to a decimal between 1 and 10, I have to make a positive compensation of 10 to the first power. But I'm still multiplying that times 10 to the negative fifth power. So now what happens here is 1 plus negative 5 is negative 4, and I'll get an answer of 1.445 times 10 to the negative fourth power. Okay, let's try one more problem. Let's do a division problem. Well, I can divide these numbers. 15 divided by 3, that is 5. And by the way, if I'd get a decimal less than 1 here, I would then have to compensate just like I did up here eventually and convert it into scientific notation. Okay, but that is a decimal between 1 and 10. But then I use my quotient rule of exponents. Negative 4 minus a negative 7. And that is going to be, I just want to make sure I don't run into this other problem here. That is going to be negative 4 plus 7, or 10 to the third. So my final answer would be negative 4 plus 7 is 10 to the third. And I'm good, because that number is in scientific notation. And once again, if I did division and I got some number either less than 1 or greater than 10, I'd have to make an adjustment, just like I took 14.45 and turned it into scientific notation here.